All right. So that's the first example. So the second example we're going to do that contains the word and, okay, is not that one. This one here. So now we actually have a problem. Here's the actual first problem, to be honest, because the first one was just graphing. So this one is an actual problem that you'll start off with, like with your homework. And first you got to solve it. So to solve it, notice that it is a compound inequality. How do I know? Because I see two inequality symbols. Okay. So I need to solve it first. So what I'm going to do is get rid of the plus 8 that's in the middle, because see how we have to isolate this variable to get y all by itself. I have to get rid of that minus 8. So how do I get rid of a minus 8? I'm going to add 8. Now this time when I add 8, I have to add it to each section. So I have to add 8 there, to the left, and to the right. Okay, so you have to put it in the middle, because you got to get the variable by itself, and then you add it to the left and right. So it's really almost working two problems simultaneously. Okay, and then you just go ahead and do, the math. So 8 minus 5 is 3. It's greater than or equal to y, which is greater than or equal to 1. Now remember, I just started off by saying that your numbers should go from least to greatest. So is this in the right order? Because this actually goes from 3 to 1. So we have to change it because we want the smaller number first. And now we reverse the symbol. Bring down your y. Reverse the symbol. Bring down your 3. Put it in set builder notation. Okay, and now you have it from least to greatest. So for set builder, you should have and I'm going to write it out, the least number first, and then the greater number next. Okay, and the variable, of course, goes in the middle. And we're going to always use the less or less equal depending on, if it has an equal sign under it or not. But it'll always be less than symbols. Okay, because you're going from least to greatest. So how do you graph this? Indicate 0 on your number line. Indicate where 1 is. Indicate where 3 is. And 1 will be closed. 3 will also be closed because of the equal sign. And then you just draw your line in between. Okay, so and is always the in-between type of thing. Okay, in this case. All right. So this is what I want you to do, because I want to do another one like this. So go to page 6 in your packet first. And we'll come back to OR in a second. And let's do question number, and this is page 6. Let's do question number 2. Now, this is an and statement. Now, how do I know? Because I told you at the beginning, you will always see the word or. So, like, you'll see the word or in number 5, in number 6, in number 7, and then number 8. Okay? So, since 1 through 4, I don't see the word or, it's automatically an and statement. Okay? Sam, not a good time. All right. So now what we're going to do is solve first, because it says solve each inequality and graph it. So I'm just going to rewrite it under here so that I can actually, add stuff to both sides. I'm just going to rewrite it. If you feel there's not enough space, by all means, you can use your spiral. So to solve it, you have to isolate this variable in the middle here. So that means I need to get rid of that positive 5, and later on I'll get rid of the times 10. All right? Always do the constant first. So I need to get rid of the positive 5, so I'm going to subtract 5 in the middle, on the left, and on the right. And draw my line. Okay, and then we just go ahead and do the subtraction. So 65 minus 5 is 60. is less than 10v is less than or equal to 100. So what do you think I should do next to get rid of that times v? Everybody. Divide by 10. Okay, so we're going to divide by 10 in the middle, on the left, on the right. So what's 60 divided by 10? 6. So 6 is less than v, which is less than what? 10. Very good. And then just put your bar for your set builder, and you're done. Okay? So again, it's like solving two equations simultaneously. So now, and I did miss my equal sign in my final answer. That should be less equal for the last part. So now we're going to graph this on the number line. So we're going to go up to 6. 6 will have an open circle on it. 10 will have a closed circle. And then we just shade it in between. Any questions on that? All right, it's just like solving both at the same time. All right, so, all right. All right, so let's go back to our foldable. All right, and we're going to take a look at this problem here. Example 3 is an OR problem. So to write this as an OR statement, this is what you would do. All real numbers, let's call that x, that are less than -4, so there you go. Or, so there's the word or, greater than -1. And you can't change an or. Or is or. Now, 90% of the time, it's not 100, but most of the time, they will be going in opposite directions. Because one's pointing to the left, one pointing to the right, and they can do that for an or statement. Okay, so to write this in set builder, this is what you would do. You would leave it just like this, put your bar, put your X again, and then just put the set brackets. Okay. Or has to be in the problem. And like I said, there's one exception, which I'll go over with you after we do a couple more examples. But or has to be in the problem. Because I do want you to know what happens if they're going in the same direction. Okay, they're you know, got to do something slightly different there. All right, so let's move on to this one. And see how you see the word or? It's going to be there. So when it's or like this, you actually just solve it like you do two separate problems. They are separated by or. So we just solve both. Let's go ahead and do that. So for this one, I'll have h is less than -2. Bring down the word or. And then we just work the other one. And we'll have h is greater than 6. Okay, we put our set builder, and that's it. You can't, that's it. I mean, you don't do least to greatest or anything like that. You cannot combine it. Okay. Yeah, this one here should be less equal, and then this one is just greater. Okay. All right, so now we're ready to just put this on a number line. So let's put 0 in the middle. Okay, we'll do -2 and 6. So at -2, you should have a closed dot, and it's shaded to the left. And for 6, it's open and shaded to the right. And as you can see, again, they're going in opposite directions. So I will go over with you what happens if they're going in the same direction in a second. All right. So those are just the problems on the foldable. That's it for that. So go back to page 6. we're going to now do an additional OR problem. Okay, so go back to your packets. And let's do question number 6. 6 is an OR problem. So I'm just going to rewrite number 6 under here. And you just work them out individually. Alright, so I'm going to subtract 8. So I'll have 5a is greater than 20. Divide by 5. So a is greater than 4 for that one. Bring down the word OR. And then I'll have 2a is less than or equal to 0. And then divide by 2. So a is less than or equal to 0. And then just put it in set total. Okay, so it's just like working out 2 problems. Put in the word OR in between. And these are going in opposite directions. You can see one's pointing to the right, one's pointing to the left. So we'll go ahead and graph that. So we have an open circle here on 4, shaded to the right. A closed dot on 0, shaded to the left. So OR is really simple. Okay, just usually they go in opposite directions. There are some exceptions. So now let's do the exception. So this is where you're going to put this in your spiral notebook for me. So these will be for OR statements that go in the same directions. So what happens if you do a problem and they're not going in opposite directions? And so what I'm going to do is just give you like what the final answer would look like. So let's say you worked out a problem and you ended up with a is greater than 2 or a is greater than 4. Okay, so see how they're going in the same direction? And I'm going to do what I call a preliminary graph first, and then the second one will be the answer graph. So I'm going to put answer by this one. I want you to see both of them graphed first before I tell you how you get the one that's the answer. So if I were to graph this, a is greater than 2, then this is what I would do. Put a 2 here. Open circle, and it's going this way, right? If I am to graph a is greater than 4, put a 4 here, same thing, open circle, and also going that way. Okay? Now, when they go in the same direction like that, you don't want to have 2 graphs. You don't want to have 2 things going in the same direction. You can only have one. Okay, so the 1 should include both graphs. Okay, so just think about what I just said. So the 1 should include both graphs, because remember at the beginning I had you to write OR means union. That means combining both answers together. Now it's easy to combine them together when they're going in opposite directions. It's also easy to combine them together when they're going in the same direction. So if I want to include a is greater than 4 as well as a is greater than 2, which one of these would I use that would actually include the 4 as well as the 2? The 2. Very good. So your answer graph would just have a 2 here with the open circle and shade it to the right. You do not do both when they're going in the same direction. So basically you start with the one that's furthest back, because that would include, you know, see how it comes across the other one? So you don't need to have this one here. Okay, there's no need for it because this one takes care of both. So when they're going in the same direction, make sure you only give me one answer. Okay, not both. So now, when you write your final answer, it has to be based on your graph. So you just say A is greater than 2. That's it. You don't say or A is also greater than 4. You don't do that. Okay, you just give me one answer, one graph. Okay, one little bubble. So we'll do another example. So example 2. So if I have x is less than or equal to 0, or x is less than or equal to, let's say, 4. And see how they're going, both are going to the left. And this is for an or statement. They're both going to the left. So my preliminary graph would look like this, a closed dot, and I'll do the preliminary one first, going this way, and then at 4, a closed dot going this way. That can't be my answer. Since they're going in the same direction, I only want to choose one of them. So which one do you think I will choose? Or which one you think is correct? Because there's only one correct answer. The 4. So this is the answer. Okay. And which means you would write it as A is less than or equal to 4. Or X, whatever I think I said. I said X at the beginning. So X is less than or equal to 4. So if they're going in the same direction, only give me one answer. Now, what if this happens? This is another case you could have. So we'll call this example 3. A is greater than or equal to, let's say, 0. Or A is less than or equal, and obviously they're going in opposite this time, less than or equal to 2. All right, let's say we had that. So let's just do a preliminary graph first of both of them. See what it would look like. I always like to, do both just to see. So I'll put a closed dot here, shade it this way, and then for the other one, here's 2. I also put a closed dot, and look, it's shaded that way. What do you think my answer would be? If I had to combine both of these together, think about it. What do you think my answer would be? This one is starting at 2 and covering everything. This one is starting at 0 and covering everything that way. So what do you think the answer would be?
0.
What'd you say? It is an answer. What do you think it would be? But look at this. This is covering all of this, right? And this is covering all of this. So what do you think the answer would be? It would be the entire number line. Just put 0 there, but you're shading the entire, which means all reals. Okay, now how do you write that in set builder? Who remembers? X such that X is an element of all reals. Yes. So that would be the entire number line, because one is covering everything to the left, other one's covering everything to the right. That's the entire number line. Okay, so that's one of those other exceptions that you could run across. I want you to know that. Okay. Alrighty. Now, one other thing I want you guys to look at. There was another sheet of paper that you picked up, which really is a copy of page 203 in your textbook. Everybody find this piece of paper here. You should already have it. And it's also page 203 in your textbook. All right. I just copied it so you'll have it. And when you're doing your homework, there are a couple problems that it asks you to do this. Interval notation. So interval notation is different from set builder notation. You guys know how to do X in the bar. That's set builder. So now there are a couple problems that say put your answer in interval notation. So, and really we just need to look at these two here, okay, because you're doing compound inequalities, and the last two examples are examples of compound inequalities. So say this is your answer right here that you got for an AND statement. Okay, so this is an AND. How do I know it's an AND? Because I don't see the word OR. Okay, and this is your OR. All right, so for this one right here, the first one, the AND, when you have this parenthesis means that the dot is open. So I'm going to put open. Okay, and the bracket, I'll put it up here. Sorry. Hold on one second. The bracket means the dot is closed. All right, I'll have to connect again. All right, so the bracket here just simply means the dot is closed. All right. Now, you also use parentheses for infinity. So positive infinity or negative infinity, okay, we use open because you can't close infinity because that means you're kind of contradicting yourself, that it stops somewhere and it doesn't. So infinity is always open, okay? That means it will always have a parenthesis. So let's take a look. Look at this. So notice how this right here is an open circle on 1. So see how they have the open parenthesis around the 1. All right. This is a closed dot on 5. So that's why you see the bracket around the 5. Okay. Does that make sense? I mean, it's a very easy notation to do. You don't even have to worry about, you know, X such that and all that. Interval notation is probably easier than set builder. Okay, now look at an OR statement. How would you do that? Because you know how sometimes you got to keep on going forever and ever. Those are your infinity symbols. So see how this one starts off going in negative infinity? So there you go. And remember, we never close infinity, so that's why you see the parenthesis. And then for the -3 that's here, it's open, so that's why you see the parenthesis around the -3. On the other side, the 4 has a bracket around it because it's a closed dot, and then it goes to positive infinity. Again, we never close infinity. And that's all you do for interval notation. Okay, so once you have your answer, just look at it and follow this page. You should be able to figure out if you're using a bracket or if you're using a parenthesis. Any questions on that? That part is the easy part. Okay, that part is the easy part. So I copied it for you so you wouldn't have to go online and look at the page. You'll already have it in your binder, and then you can just flip and look at it as you're doing your homework. All right, any questions on that? Okay, all right, so how much time we have? That's 2:08. 2:08. All right, so we don't have a whole lot of time. So I'll let you guys